Hi, I'm 3 honor students. I'm going to teach lessons 7-9, 7-10, and 7-11 with you right now. So 7.9 is about the complex number I. 7.10 is about complex numbers, adding and subtracting them. And then finally in 7-11, we're going to talk about complex numbers some more. And this time we're going to be multiplying and dividing. All right, so let's go ahead and get into these 3 sections. So first off, if I ask you to do the square root of a -1 or square root of a negative anything, up to this point you probably have said no real solution. Well, now we're going to get into imaginary numbers and complex numbers. So whenever you see the square root of a -1 and you're allowed to go past real, okay, what you're going to say that this is the same as I. So for example, if I said, what's the square root of a -9, you would tell me 3i. Or what's the square root of a -49, you would tell me 7i. Okay. Now there's some things that kind of go with this. If I were to do I squared, so it'd be this times itself, you're going to get -1. If I were to do I to the third, which would just be an I times an I squared, so if I multiply those together is a -I. And finally, if I do an I to the fourth, that's basically an I squared times an I squared. So it's a -1 times a -1, 1. And then what you know about i's, or what you'll find about i's if you have to go much further in your math career with them, is that they cycle in 4s. So like this, and so these would be the answers that you would have. So this is I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th, so forth and so on. It just cycles in the 4s. So the ones that we're going to be dealing with the most in our class here is whenever I see a square root of a -1, I'm going to make it an I. So if I just see a square root of a negative, I'm going to pull it out so I can get rid of that square root of a negative and have an I. And whenever I see an I squared, I need to change that to a -1. Those are the 2 things that we'll probably see the most. Okay, so let's try some examples with this for this first section on 7.9. So for example 1, let's just simplify. So in part A, say we do 5 times 7i. You're just going to, in this case, treat the I like an X. So if I do 5 times 7i, that would be 35i. And I is as simple as you can get it, so I don't need to break that down more. So part B, say I have a 3i times a -8. So same idea. If I multiply those together, I'm going to get a -24i. Part C, say I have a 4i times a 9i. Okay, so when I multiply, the 4 times 9 is 36. I times I is an I squared. Okay, and as we have over here, an I squared is the same as a -1. So that's 36 times a -1. So my answer would be -36. Okay. Now another way that you can think of an I squared besides a -1 is you can think of it as an opposite, because -1 and opposite kind of work hand in hand in that case. So me personally, when I see a 36 I squared, I know that that's going to be the opposite of what it is, so it's a -36. Okay, so if you want to think of the I squared as a -1, which it is, you can do it that way. Or again, you can always think of an I squared as making something the opposite of what it is. Just keep going. Part D. Say I were to give you a 10i squared. Since we've got 2 factors inside, we got to make sure we square them both. So we've got a 10 squared, which is 100, and then we also have the I squared. So again, put your I squared as a -1 or think of it as an opposite. I'm going to think of it as an opposite in this case. So that would be a -100. And finally on this one, oops, don't know my alphabet. Let's try part E. So let's do 6i to the third. So 6 is 6. Now I to the third we can break down. So we can kind of look over here. I to the third is the same as a -I or the opposite of I. So if I multiply that, I'm going to get a -6i. Okay. All right, so let's use this idea and break down some more. So in example 2, let's simplify. So in part A, say I give you the square root of a -28. So -28 obviously is not a perfect square. So we're going to look, again, I'll just write these off to the side as to my perfect squares. We're always going to look and see and so forth and so on if we have any perfect squares in here. Now the first thing you have to do though is you have to clear out the I. So I've got to take the I out first. Have to. And now I break down my 28. So if I start, half of 28 is 14, starting right here. Does 28 divided by 9? Nope. Does it divide by 4? Yes, it does. And it's 4 times what? 4 times 7. So when I do my answer, I'm going to show you two ways that you can write it. It's totally your choice. If I do the square root of 4, that would be 2. So I have my 2I root 7. Another way I could write this if I want is I could do 2 root 7 and then the I. Just be very careful when you write it this way because you got to make sure that the I is not underneath the square root. Okay, so whichever way that you are comfortable writing it, you're more than welcome to. I tend to write the I in front of the root just because I don't want to accidentally tail my root over the I. All right, let's try this again for part B. Say I gave you the square root of a negative 64 plus the square root of a negative 18. All right, so first off, I know that 64 is a perfect square, and I have my negative, which is the I. So this here is just an 8I. On this one, this was not perfect, so I got to break it down. So I'm going to pull out the I first, and then 18, the biggest perfect square is 9. 9 times 2. So when I have my answer, the 8I is just 8I. And then the square root of 9 is a 3. We got your I and then the root 2. Now I cannot combine those because they're not like terms. This one has a radical, this one doesn't. So you would have your answer right there. And again, I could always write that as 3 root 2 I if I wanted to. Part C. Say I have the square root of a negative 3 plus the square root of a negative 75. Okay. First thing I'm going to do is I'm going to take out the I. Can I break down a 3? Nope, there's no perfect square, so it's going to stay square root of 3. Here again, take out the I. And then what's the biggest perfect square in 75? It's 25. So this is 25 times 3. So I'm going to have I root 3. The square root of 25 is 5, so plus I root 3. If you notice, these are both I root 3s. So one of them plus 5 more would be 6 of them. So I'm going to have 6I root 3. Again, or if you would like to, you could write it as 6 root 3I. So 6 root 3. Just make sure that I is on the outside. Whichever way you're more comfortable writing, your answer is correct. So let's try one more on this one. So part D. Part D is the square root of negative 10 times the square root of a negative 5. So now this is when I do see quite a few mistakes on, so make sure that you're paying attention here. All right, when we do multiplication of radicals and you're dealing with the negative underneath the root, you've got to take out the negative first. So if I take out that negative first with my square root, I'm going to have an I, and then I have my root 10. Same thing here. I've got to take out my I first, and then my root 5. So when I multiply, I times I is an I squared, and then a root 10 times a root 5 is a root 50. Okay, so I know an I squared is a negative 1 or the opposite, so I'm going to put a negative, and then 50 breaks down into 25 times 2. So then my final answer would be negative, and then the square root of 25 is 5, so negative 5 root 2. So that is what your first section 7.9 is going to look like. You're just multiplying your i's and making sure you're simplifying it down, or you're breaking down your radicals that involve i's. All right, so now on to 710 and 711. So they're going to bring up this idea of what is called a complex number. So when we are talking about a complex number, in standard form, a complex number is a plus bi, and you need to make sure that you write your answers in standard form. So again, standard form would be a plus bi. A is always going to be the real part, and then b, the bi, is always going to be the imaginary part. All right, so let's try a couple of examples with this. So example 3. So example 3 is going to ask you to simplify. So in part A, say I gave you the quantity 3 plus 4i, or the complex number 3 plus 4i, and I ask you to add that to the complex number 8 minus I. So what I notice is that what's in between these two parentheses is a plus sign. So what that means is all I'm going to do is combine like terms. So for those of you that can see what you can combine, you can already give your answer. For those of us that might need a little bit more structure, nothing in front of this first one changes, so I don't need the parentheses. And then I'm just going to line this one up. Since there's just a plus, nothing changes in this one. So I'm just going to line it up, my real with my real, imaginary with my imaginary, and then I'm just going to combine. So 8 and 3 make 11. 4i minus I is a 3i. And then I just got to make sure I have in standard root form before I box it. Is it real plus imaginary? Yes, it is. So that is my answer. Okay, let's try this again. In part B, you've got the complex number negative 5 plus 2i, and you're going to subtract the complex number 6 minus 3i. Okay, so again, I notice that I have a plus or I have a minus in between my two complex numbers, so it just means combine like terms. Okay, so I'm going to, again, structure this a little bit more so I don't make a mistake. There's nothing in front of this first parentheses, so it's pretty much like I don't even need it. And here, I just got to make sure I make both of those the opposite. So I'm going to have a negative 6 and a positive 3i. So when I combine, I have negative 11 and I have a 5i. Now before I box, it's got to make sure I'm in standard form. Real, then imaginary. Yes, I am. So I am good. Hopefully so far so good on how you do this. So now that's basically a good amount of what's in 710 is you're just combining like terms. And there's another one I'll show you in a second. But let's go ahead and go to example 4. So in example 4, it's going to ask you to simplify. And say I have the quantity 6 plus 5i times the quantity 2 plus 3i. Okay, this time I don't see a plus or a minus in between my two complex numbers, so this means I need to distribute. So when I distribute, distributing there gives me 12. Distributing there gives me an 18i. Distributing there gives me a 10i. And distributing one last time is a 15i squared. Okay, so we've got our 12, we've got our 18i, we've got our 10i. Now again, for the 15i squared, think of it as two things. Either you think of your I squared as a negative 1, so 15 times negative 1, negative 15. Or again, you can think of your I squared as the opposite. So if it's the opposite, this becomes a negative 15. So now when I combine like terms and in the right order, so I'm going to do my real first. 12 minus 15 is negative 3, and then an 18i and a 10i is a 28i. So that is how you multiply complex numbers. All right, so I need to mention one thing before we can divide complex numbers, which will be our next example. So the thing I need to mention to you is what is called a complex conjugate. So when you have like your a plus bi, the complex conjugate of this would be a minus bi. So what I hope that you notice is that the real is the same, the imaginary is the opposite. Okay, so let me see if I have a different color to mention that. So again, real stays the same. The imaginary part becomes the opposite. So imaginary is the opposite. And the whole reason we're going to use a complex conjugate is because if I multiply them, it just becomes a real number. And you'll see this in our next example. So example 5, it's going to say simplify. Say I gave you 6 plus 3i all over 5 minus 2i. So if you need to write a little note to yourself, whenever you're dividing, nothing is simplified if you have imaginary in the bottom. So when I see that I have an imaginary in my denominator, I know I'm not completely simplified. So what's going to get rid of my imaginary in my denominator? It's complex conjugate. So what I'm going to do is I'm going to multiply top and bottom by the complex conjugate of my denominator. So again, this is the one that I need to make sure I'm doing the complex conjugate of. So as we mentioned right here, the real stays the same. So this is going to stay a 5. And then what's going to become the opposite is the imaginary. So it's going to become a positive 2i. Okay. And then what I need to do now is I just need to simplify from there. So I need to multiply those together, and I need to multiply those together. So distribute is 30. Distribute is a 12i. Distribute is a 15i. And distribute is a 6i squared. Now on the bottom, I notice that this is a difference of squares. I got something plus or minus something else. Whenever I have a difference of squares, all I need to multiply is the first and the last. So 5 times a 5 is 25. A negative 2i times a 2i is a negative 4i squared. Okay, so let's keep going. All right, so I've got my 30, I've got my 12i, I've got my 15i. I know that this 6i squared, I like to think of it as an opposite, so it becomes a negative 6. And on the bottom, I've got my 25. Again, I have another I squared, so it's the opposite. This will be a plus 4. All right, so we've got, let me just go ahead and combine. Sorry about that. All right, so if I do 30 minus 6, that is 24. 12i and 15i is 27i. And on the bottom, when I combine those, that would be 29. Now I've got one more step. In order for us to have an answer when it's a complex number, it's got to be a plus bi. So I've got to have my real, then my imaginary. So I just got to split these up and reduce if possible. So I'm going to do 24 divided by 29. That doesn't reduce, so it stays 24 29ths. I see a plus, and then I got to divide these as well. And those don't reduce, so it's 27 29ths, and then just don't forget your I. So that is how you divide complex numbers. Okay, so again, we've mentioned what is an imaginary number, what is a complex number, how do we multiply them, break them down, reduce them, add, subtract, multiply, divide. So now there's one last example I want to do with you. So this is example 6. I want you to solve for x and y. Say we have 3y plus yi is equal to 2i minus xi plus x. Okay, so we have two variables we have to solve for, and we're throwing in some i's. So what we're going to do to solve this is we're going to make a system. I notice that some of these terms are real, some of these terms are imaginary. Okay, so what I'm going to do for my system is I'm going to set up a system where I have the real all together and where I have the imaginary all together. All right, so if I look on the left-hand side only, so let's ignore the right-hand side. So if I look on the left-hand side, what's the real part? The real part is a 3y. So I'm going to say 3y equals, because that's the real part. Now I go to the imaginary part. What's the imaginary part here? The yi. I'm not going to write the I though, because then that's just going to confuse me on some things. So I'm just going to write the y. Okay, so one more time. The real part on the left was a 3y. The imaginary part was the yi, but you just ignore the I for right now because we're going to try solve. Okay, now let's go to the right-hand side. So on top I have real. So if I look over here, what's the real that I have? The real is the x. Okay. Then I look at the imaginary part. What's the imaginary part I have? This one here. So I'm just going to write what I have, except ignore the i's. So I have a 2 minus x. Okay, so now what do? I just solve the system. And again, you can solve it however you want. I'm going to do it substitution because it looks the easiest. I'm going to take what y is and plug it in for y. So I have 3 times y's new name, which is 2 minus x, is equal to x. So that would be 6 minus 3x is equal to x. Add the 3x over, which is 4x. Divide both sides by the 4, and I'm going to get 3 halves. So my x is equal to 3 halves. Now the question said solve for x and y, so I got to make sure I do both. So I'm just going to plug it into the bottom. So 2 minus my 3 halves, my y is equal to 1 half. All right, and that's the end of chapter 7 and section 7.9, 7.10, and 7.11. So good luck with your work, and let us know if you have any questions.